Hello and welcome to another episode of Climate Watch. I'm Fei Fei. Since mid-June, many parts of the world have been gripped by extreme weather events. From the Americas to Asia, countries and regions are facing multiple climate challenges like torrential rains, floods, and others. In the United States, the death toll from flooding in Texas continues to rise. In China, record-level flooding hit the province of Guizhou, and the Ministry of Water Resources has issued emergency flood control responses for several other provinces, including Zhejiang, Fujian, Guangdong, and more. Official meteorological data shows the rainfall last month was nearly 70% higher than the average for the same period. As we face more record-breaking rain and flooding, what new solutions are being explored? One answer may lie in a super smart system. Here in China, smart water systems combine digital technologies, intelligent simulations, and precise decision-making with a core focus on building digital twin river basins. These systems are driving the development of advanced computing infrastructure and accelerating the rollout of intelligent water management platforms that integrate forecasting, early warning, simulation, and emergency planning. The goal is to safeguard lives, reduce secondary disasters, and improve overall water resource management. To learn more about China's smart water systems, Zhou Fang spoke with Professor Cao Ying from Sichuan Agricultural University, an expert in water resources and hydropower.
Professor Cao, thank you for joining us. Can you introduce what smart water system is?
Actually, nowadays, the China government wants to build a water management system to face the challenge of the normal water management and the extreme climate events. So the smart water system is the digital scenario, intelligent simulation, and precise decision maker as the main functions. It's centralized on building digital twin river basins. We will comprehensively advance the construction of the computationator and the computing power, accelerate the establishment of smart water conservation systems to forecasting, the early warning, and simulation and the congestion planning. The purpose for the smart water system is to reduce the flood side effect and save residents' lives, and to better operation the reservoir and other hydraulical infrastructures.
Compared with conventional water management systems, this smart water system, what core technologies are needed to be integrated into the conventional one so that it will become smart?
Actually, for the smart water system, usually we will use like the real-time radar, the IoT sensors, also the satellite-based participation monitoring, and the precipitation radar to get the rainfall information, the distributed sensors networks, and automatic converse on servers, also the AI intelligence. All the tools, all the technologies is to turn the rural water management from reactive to proactive, crucial for handling the new normal of climate amplified extreme events.
Let's dive deeper into this. I was wondering what specific roles have smart water systems played in addressing climate change-induced floods and droughts. Then, facing climate change, what can we do with all these smart water system models and technologies?
Actually, the most important of the smart water system is transfer the passive infrastructure into adaptive neural networks, which is using the real-time data and the AI to navigate this valuable new normal. This technology and the toolkit we usually use like the real-time radar, the IoT sensor to get the AI flood forecasting, or automatic gate pump or pre-release water. And we also use the satellite-based participation monitoring to dynamic the interbasin water transfers. We also use different sensor distribute in the soil and the rainfall to precisely the irrigation to reduce the waste of the water. So by using these tools or technology, we can transfer the conventional water management to against the climate amplified hydraulic chaos.
Actually, according to the Ministry of Water Resources, one of the key objectives is to establish a smart water management system with the functions of forecasting, early warning, simulation, and contingency planning. In Chinese, it's called 四御. Then why are the four functions important?
These four functions is the main scenario for this smart water system. For example, the forecasting harness over 12,000 IoT stations and AI model to extend the flood prediction leading times to 3 to 7 days to countering the outdated historical baselines. For the early warnings, achieves the 90% county coverage with sub 10 minutes allowed to let the civilians get out the flood area. The simulation is to simulate over 200 annual flood and drought scenarios, and the contingency plans standardized response across 28,000 reservoirs. So it's the climate adjusted threshold to handle these climate change extreme events.
Then, how has the country progressed in terms of the establishment and implementation of the four functions so far? I mean, are there any successful applications of these four functions when it comes to making forecasts or early warning or even simulations?
Actually, nowadays, China has lead in real-time forecasting scale and automated control. For the Yangtze Basin, 85% drought forecast accuracy and 7 minutes warning system has been built. We also participate one of the Qinyijiang River Digital Twin Basin in Sichuan Province. It has 120 IoT sensors, satellite remote sensing, and AI-driven hydraulic models into a dynamic 3D simulation platform. For the high-pressing flood forecasting is 22 hours leading time with more than 90% accuracy. And it's also had a rehearsal of extreme scenario, simulation of over 100-year storms amplified by the CMIP6 climate projects. During the 2022 flood season, it also reducing flood peak by 50% and protecting 1.2 million residents.
You also mentioned the digital twin systems, and actually the construction of digital twin river basins is pivotal to our country's smart water management system. Then what is the significance of building digital twin river basins? Can you explain briefly how they work and how we will benefit or how we have benefited?
The digital twin river basin is fundamentally enabling proactive the climate adaptation through these functions. One is for the replicas of the entire watershed. The second is integrating the real-time data. The third one is to simulate. The most important is they address the critical challenge of non-stationarity, where historical hydraulical data becomes outdated due to the climate change. And usually, it works as a data fusion. The thousands of IoT sensors, satellites, and weather radars feed live data on rainfall, soil moisture, river flow, and reservoir levels into the twin. The second one is a hydraulic AI modeling to machine learning. The third one is scenario testing to run what-if rehearsals to stress test infrastructure. The last one is automatic control to adjust dam gates or detecting pumps when the threshold are reached. One of the examples is, as we just mentioned, about the Qingyi River digital twin. Another one is about the Yangtze River digital twin, and also the Yellow River. We had built the same system to do this work.
You talked about the Yangtze River digital twin system and the Yellow River digital twin system because, these two rivers are so important for China. We have so big a population living nearby, and we also have agricultural practices there. So I was wondering, have the digital twin systems brought any benefit for human beings or agricultural practices, especially when we face unpredictable or extreme weather events?
For example, the Yangtze Twin project in 2022, it reduced the flood peak 50%. It predicts before the flood 72 hours to automatic control of the dam gates, and it also guarantees the agricultural land irrigation water, and they also increase the ship carriage more than 1,012 tons.
We know recently Rongjiang County in Guizhou province was hit by floods unseen in 50 years. And unfortunately, the floods caused damage and casualties. Since we're talking about smart water systems, can you tell me how smart water systems can work for the prevention and control of such disasters, or maybe coping with the floods?
Actually, the flood in Rongjiang in this year, which is caused by the geography and also the extreme rainfall within few days, it rainfalls half a year's of average. So we can see the flood is extreme side effects to the local people. Actually, since 2019, Rongjiang built the first Guizhou province urban flood warning platform. The system integrated the real-time radar and drone-based 3D terrain mapping to simulate the flood with 3 to 6 hours latent time. In that year, it evacuated of the 51,000 residents. So the smart water system played an important role to protection the flood. But in this year, it's due to, we just mentioned, the geological and the extreme rainfall. So the flood plays very bad outcomes. In the future, I think there may be enhanced climate models, the satellite backup systems will support more resilience in these remote villages and other areas.
Of course, more innovation will always be needed to help us better navigate the situation and better adapt to climate change-induced disasters. You also mentioned multiple times the use of data, like IoT sensors. They collect data, and then, according to the Ministry of Water Resources, they will promote data sharing within the water industry, while also enabling data sharing with other sectors. My question is, what specific role does data play in smart water management systems? Which could be some of the other sectors that can share data with the water industry?
In my opinion, in the smart water management, data serves as the central nervous system, enable the real-time decision-making to do the right decision-making. It can integrate in the IoT sensor networks, the satellite imagery, and the climate model to forecast the floods or droughts with more than 19% accuracy. It can also automatically control the hydraulical infrastructure, like the dam gates and the reservoir and others. It can also system optimization, balancing the water allocation across the agriculture, industry, and the ecology, using the AI-driven demand supply simulation. We can also share the data from the agriculture sector and the energy and the power grids, and also the urban management. Also include the transportation sector to build a more smart water system.
And then there are different real battles to fight using these technologies, such as extreme weather events, floods, and droughts. So I guess there are still challenges. What are the key challenges, would you say, China faces in building its smart water systems?
Like any other project, I think the primary challenge is about the money. The smart water system needs to build a lot of sensors into the different area. And they also need training the AI model to simulate different scenarios. The traditional water management systems will also be single scenario, such as a flood or drought. But in nowadays, we face them in the same time. So we need more professional engineers and more professional staff to join the smart water management systems. The third one is we just talk about the data. The data fragmentation is also another important challenge. There were more than 13 provincial water authority and the legislative system higher integration. So that means a lot of work to get the data integrations. And we also means about the technology disparity, the climate uncertainty. They are all important challenges.
China is not alone in building its smart water systems. As far as I know, smart water systems have been around for some time. Countries like the Netherlands and Singapore are known for their smart water technologies. Has China collaborated with other countries in this field?
China focuses on the technology transfer, joint the research and development, and also the business skill relevance. For example, the Lanchang Mekong Cooperation Water Center, which reduced 13% in flood forecasting error across the basin using the shared hydraulical data and the AI model. Another one is about the China-Netherlands sponge setting programs. 14% faster stormwater absorption in pilot zones, reducing the urban flooding during the 2023 typhoons.
Professor Cao, really a nice chat with you, and thank you for your great insights.
Thank you, everyone.
A huge thank you to Cao Ying with Sichuan Agricultural University, and thank you for listening to this episode of Climate Watch. If you enjoyed this episode, don't forget to subscribe to this podcast, leave us a quick review, or share it with a friend. Until next time.